Morning, everybody. So I welcome all sixth semester students for the next session, that is session number 8 of software testing. Yes, fine. Just we'll recap the things what you discussed. So in the last class, you discussed about two things, that is developers as testers. And in today's classes, we'll discuss independent team testing, buddy testing, testing phases, and V model. So these are the topics what we're going to discuss in today's session. So as we already discussed developers as testers, just we'll recap the things once again. Yes, fine. So yesterday we discussed developers as testers, what are the advantages, and so the developers are familiar with the user requirements, yes, and structure of the program, so they can do testing very efficiently. And what type of testing they could do? They can do unit testing as well as integrating testing. They can do very efficiently, as you discussed yesterday. Yes, so developers are familiar with the user requirements and then structure of the program. Hence, they can carry out the two types of testing, that is unit or component testing or integration testing. Yes, fine. Next, then next, what are the advantages if what you call an independent team is doing the test? Yes, so now for example, now developers are not doing the testing. So if the developers are doing the testing, so what they can say that there are no bugs in the program, but they have written the program and they might do the testing, no doubt, but they may unable to identify the what you call errors or bugs, what you call. So if other than developers, if they do testing, if an independent team does the testing, so they will do impartial testing. Whoever the code has written, whether it may be his friend or anybody, irrespective of what you call individual, so the testing team is going to do the perform the testing there. So they may find the bugs in the program, so that what you can call the quality of the software can be improved, what you can call. So following issues need to be considered if test engineer does the testing. So if an independent team does the testing, what are the factors we should keep in mind? So we'll discuss that. Is the test engineers need to have an excellent knowledge about an SRS document, design document, etc. SRS, software requirement specification document, design document, etc. So the test engineer should know what is SRS, what is design document, and so on. If they know the design, if they know the SRS, then only they can do testing thoroughly and efficiently. If they doesn't know the design and if they doesn't know the SRS, they cannot do thorough testing, what you can call. Yes, so they should know the SRS document as well as the design document, what you can call. Yes, fine. Next, yes, if the test engineers have to do, what you can call do the code reviews, they need to be familiar with the programming. Yes, they need to be familiar with the programming. So whoever the test engineers, if they want to do testing in what you can call C programming, the test engineer should have the C knowledge, Java or Java knowledge, or Python knowledge. So they should be familiar. If they're not familiar, the test engineers, then they cannot do testing at all, what you can call that. Yes. So whoever they're doing the testing, the test engineer should be familiar with the corresponding, say, what you can call source code there. So whichever language they may be there. Yes. Whichever language they are doing, the software project has been developed. So that language they should be familiar, what you can call this. Then the test engineers need to constantly interact with the developers. Yes, so they need to interact with the developers, what I call that, because they may be having some doubts. The test engineers, they may not understand the logic or they may not understand the code. So they need to continuously interact with the developers. Is it because the developers have written the code, the test engineers may not understand, or if there are bugs, what is the reason for generating the bug, or they may ask something there. So always there should be an interaction between the developers and the test engineers. The test engineers need to realize that the developers are emotionally attached to their work. So unintentionally or intentionally, you should not hurt the developers. See why? Because so the developers have written the program. If you say that you've done wrong, so they will be emotionally hurt, you can call. So you politely tell them that there are bugs in the particular program, rectify that. So politely should tell that. That is what. So the test engineers need to realize that the developers are emotionally attached. They may tell, the developers may tell, simply you are telling there are no bugs in the program there. So that's what. So politely the test engineers should tell that there are bugs, so kindly rectify those bugs, what I call that. Yes, fine. Yes, next. Yes, test engineers. So here we discussed that developers can do two types of testing: unit testing or component testing, and integration testing. Now the test engineers can do the other two types of testing. We call that as system testing and acceptance testing. There, So this cannot be done by the developers. So the test engineers can carry out the following types of testing, that is system testings and acceptance testing. That's fine. When two people sit together and do the testing, it is called as buddy testing. What is the buddy testing? So buddy testing is nothing but one programmer is there, is what you can call, at the same time one coder is tester is available. So whatever the program is writing, is going to test the code at the same time. That is what we call buddy testing. When two people sit together and do the testing, it is called as a buddy testing. Here the test code is written while the actual code is being developed by the developer. So when the developer writes a program, parallelly at the same time, one more test engineer will be with him and he will test the code at the same time simultaneously. So that is what we call buddy testing. Here the test code is written while the actual code is being developed by the developer. It is difficult to implement this method because the tester should be familiar with the code and resource requirement. So at the same time, when the developer is writing the code, the tester should be familiar with the code there, or you should know the language, whichever language the developer is using that. If he's not familiar, then you cannot do what you can call buddy testing that. So the test engineer who is testing the code at the same time, when the developer is writing a program at the same time, writing a code, so the test engineer should have the knowledge of the particular source code that. It is similar to extreme programming concept. So this buddy testing is also called similar, not also called, it is similar to what you can call extreme programming, what you can call extreme programming concept, what you can call. It's fine. That is about your buddy testing, what you call. It's fine. Next, so what are the various phases of what you can call testing? There are various phases are there. What are those phases? We have discussed, as you have seen in what you can call software development life cycle, there are various phases are there. So here also there are various phases. SRS document and design document are tested through reviews and inspection. Review is nothing but checking the things what you have done there. Software requirements office specification document is checked again and again, review whether it is right, the design is right. So before being implemented there. Why? Because if the SRS or your design is wrong, then hence actually your code also will be wrong. As in the case of your building a house, if your foundation itself is wrong, then your house will also not be strong enough, or it may be wrong there. So design, your foundation, the foundation should be strong. Then automatically house will also be strong. The same way here also, the SRS, your design, your requirement should be proper. If they are proper, then definitely your code will be correct and hence you'll get the desired output as per required for the customers. Is it clear? Software is tested via a dynamic testing by executing the code. So there are two types of testing that we'll discuss again in detail: static testing and dynamic testing. Whereas static testing is a testing done manually without executing the program. Whereas dynamic testing is a testing where the code is actually executed and then we do testing. That is what we call dynamic testing. Like as you execute your Java programs or ADA program, you execute it. So that is, and then you generate, you check whether the output is right or not. That is what you call dynamic testing. Without executing, when you return the program, you check line by line, syntax error, logic error, without executing. We call that as a static testing. Yes, fine. Then we are going to discuss the various phases here. So there are two testing phases. We call them as reactive testing and preventive testing. What is that? We are going to discuss. That's fine. Yes. So here, the testing phases are given by what you call a model. We call that as a V model. What you call it? V model, in which it's in the form of a V shape. So it is called as a V. The various phases are there. So we'll be discussing that. So V model shows the various development phases and the corresponding testing phases. You can see the diagram here below. Just see the diagram. Yes. So this is the V model diagram. What you can call this. It's V model. See, user requirements. So these are the various phases as you discussed: user requirement analysis, system requirements engineering, architecture engineering, design, and coding. Yes, this one. So you do testing for each phase that corresponding. So during coding, at the bottom, the lowest level, we call that as a unit testing. So we do testing, unit testing or component testing. Then after unit testing comes your subsystem or integration testing. What you can call subsystem or integration testing. After subsystem or integration testing, we're having system integration testing. Then after system integration testing, we are having the system testing, and the last is acceptance testing. You can see here corresponding testing. At the user requirements engineering, we do acceptance testing. At system requirements engineering, we do system testing. At architecture engineering, we do system integration testing. For design, we do subsystem integration testing. And at the coding level or fabrication, we call this more lowest level, we call that as a unit testing. So this, as the various phases are there, so for corresponding phases, we do the corresponding types of testing. So these are the various phases of what you call testing phase: acceptance testing, system testing, system integration testing, or subsystem integration testing, and the unit testing. So this model, we call this as a V model. It is in the first form of a V shape. So it is called as a V model. It is in the form of a V model. So in the exam also, they may ask you this as an exam for 10 marks question. Explain V model. What is the different phases of testing in the form of V model with a neat diagram. So this diagram you need to draw, and you need to answer the following. For description, you should write. So we shall discuss this. What are the points available? Yes. So this will be very. V model shows the various development phases and the corresponding test phase. I have seen. You have seen in the diagram just now. From user requirement, software requirement specification document is prepared. For each phases, a document is being prepared. Yes. For user requirement, software requirement, design, everything, we are going to prepare a document. Based on the SRS document, the design is carried out and the design document is made. Based on your software requirement specification, the design is being implemented. Yes, based on the design, the various modules are designed, and each module is further divided into units or components. So based on the design, your project may include large number of modules, and each module will be developed by large number of software engineers, what we call that. Yes. So every module will be tested. So that is what we call unit testing, or we call as a component testing. Each unit or component is coded and tested, what we call. Yes, coded and tested each. So each module is further divided into units or components. Each unit or component is coded and tested, what we can call. The components are integrated into modules, and modules are tested. Then all the modules link together, and we do integration testing, what we call. Link all the modules and we do testing, we call that integration testing. Module testing is done to check whether the design is correct or not. When you do integration testing, we check whether all the proper modules are properly working or not. We can call this. Fine. Next, after the modules are integrated, system testing is done. So when all the modules link together, then we do a testing. We call that as a entire system testing. After system testing, the software is tested by the customer, and this is called as acceptance testing. The lowest level is the unit testing or component testing. So after that comes all the modules linked together, integration testing. After integration, we do the testing. When all the modules link, we call that as a system testing. After system testing, the software is tested by the customer, because you're developing the software for the client or the customer. So he is going to test whether the software or the project, whatever your his requirements are there, whether the output is obtained is correct or not, desired output is obtained or not. He is going to check. So we call that as a acceptance testing. What we can call, we call that as a acceptance testing. So the user, or so the client or the user will check the testing. We call that testing as the acceptance testing. It may be in his environment, or it may be in the organization, whatever, but we do the testing. We call that as acceptance testing. After acceptance testing, the software is installed in the operational environment and tested. This is called as operational testing. See, you do testing after installing at the customer's environment, what you call. It's a customer's or client environment, or his system or his environment, and check whether your software is working in his environment or not. So this we call that as a operational testing protocol. So these are the various phases of testing. So there are various phases. The lowest level is unit testing. Second is the integration testing. Next one is the what do you call system testing, and the next one, the last one is acceptance testing. After that, we'll be having operational testing, what we call. Yes, fine. Yes, this is the diagram as you see. So for every phase, there is corresponding testing. For user requirement, acceptance testing. For system requirement, system testing, architect, engineering or design, we can call system integration testing, or here for design, we do testing, it is integration testing, and coding, which is smallest level, we do a testing, we call that as a unit testing. Yes. Just 1 minute. So these are the things what we need to discuss in today's class. Some other things are there as well. Just a minute. Fine. These are the things. Yes. What is that? Just we'll discuss these questions. What is the first question? Yes. Which of the following tests does the developer carry out?
Both A and B.
So developer will carry out two types of testing, that is unit testing and integration testing. Yes, fine. Next one. Yeah, what it is called? When two people, developer and tester, sit together for testing, then it is called
Buddy testing.
it is called as a buddy testing. When the developer as well as at the same time a tester is there, so we call that as what we call a buddy testing, what we can call. Yes, fine. Yes. What is called, if the testing is started in the early phases of development, then it is called early phases of development. If the testing is started in early phase, beginning phase, yes, we call that as a preventive testing. That so you don't want further errors in the program, we do testing in the beginning itself, we call that as a preventive testing, what you call early phases of development, we call. Yes, fine. That is what you call preventive testing. It is not integration testing, it is not reactive testing, it is a preventive. So we don't want errors in the further in the future phases, so we do testing right from the beginning, we call that as what you can call the preventive testing. Next question. Yes. Which of the following test does the test engineer carry out?
Acceptance testing.
Which one?
Yes, sir.
Acceptance, yeah. So unit testing and integration testing is done by the developer. So the tester will carry out acceptance testing, and one more, which one? System testing. So both. So here the option is acceptance testing. Any other questions? No, this was the textbook. Yeah, just if you will recap the today's session once again. We'll recap the things, then we'll finish off the class. That is fine. Yes. So here we have discussed this. This is over today's class. Yes. Yeah, if an independent testing team does the testing, they can do impartial testing, as we have discussed. That is fine. So what are the advantages, if what you can call, or following issues need to be considered if test engineer does the testing there. What he has to do, the test engineers need to have an excellent knowledge about SRS document, design document, and etc. Yes, somebody read these points. Second slide, next slide. Read these points.
If the test engineers have to do the code reviews, they need to be familiar with the programming language and source code. The test engineers needs to constantly interact with the developers. The test engineers needs to release that the developers are emotionally attached to their work.
Yeah, so they need to identify the bugs, and they need to interact with the developers continuously, and the test engineer should have a knowledge about the programming language, whichever the source code the developers are using it. Yes, fine. Then the test engineers will do the following types of testing. Which are those?
System testing, acceptance testing.
System testing and acceptance testing, what it called. Yes. So what is this? This is your buddy testing. What is buddy testing? Go through it.
When two people sit together and do the testing, it is buddy testing. Here the test code is written while the actual code is being developed by the developer. It is difficult to implement this method because the tester should be familiar with the code and the resource requirement. It is similar to the Extreme programming
concept. When two people
contains.
sit together and do testing, one the developer at the same time tester, so we call that as a buddy testing. It's fine. Next. Yes. So again, there are different phases are there. So again, I told you static testing and dynamic testing. Static testing is a testing without executing, you do it. We call that as static testing. Whereas dynamic testing is a testing where you're going to execute the code and do it. That is what we call dynamic testing. Again, there are two testing phases: reactive and preventive. Due to testing, we when there are any bugs are there, we do testing. We call that as reactive testing. And to prevent the bugs further, we do in the early phases. We call that as a preventive testing. What you can call this. Fine. Then we have seen the various phases, development phases of the V model. So in the diagram, we have seen corresponding phases are there. Each each phase has got a particular types of testing. So the smallest level is for coding. We have got unit testing. For design, we are having integration testing. For architecture, we are having integration testing. And system requirement and engineering, we are having system testing. And user requirement engineering, we are having acceptance testing. So these are the various phases of software testing. And this model, we call that as a V model, what we call that is fine. Yes. So these are the things we need to discuss. So with this, I suppose we'll wind up today's class. Yes. Fine. Any other things? Yes. So we'll wind up and we'll we'll continue the class in the next class tomorrow. Okay.